Welcome back. In this problem, we're given this crazy complicated formula, and we want to know how many moles of an atom are in a certain number of moles of the compound. So we are converting from moles of a compound to moles of an atom. And for that task, we need to make sure that we use these subscripts, okay? The subscripts are those numbers in the chemical formula. All right, so let's jump in and see how this works. Now, we first need to set up the equivalency. And so 1 mole of this formula is equal to 24 moles of hydrogen. So we're ignoring all the other numbers and just using that 24. When we set up the conversion, we're starting with the starting quantity given to us in the word problem, 1.0 moles of this stuff. And I'm going to write out the formula. Okay, we want to create a fraction bar, and then we want the starting units to cancel. So I want the 1 mole of the compound made a little error there. Okay, to be on the bottom so that the moles of the compound cancels, right? And on top, I'm going to have 24 moles of hydrogen. Okay, so what that gives us after we round everything off is 24 moles of hydrogen. Okay, and that's how you do these problems. Let's do carbon. So in B, we first, again, we want to write out the equivalency that will allow us to create the conversion factor. And in this case, we're interested in carbon, so there's 20 moles of carbon in one of those guys. Okay, so let's set up our dimensional analysis. In this case, we're starting with 5.0 moles of this chemical. And what we want to have here is the moles of compound on the bottom, so it cancels. And we want 20 moles of carbon on the top. And so we do this on our calculator, and we get 100. So you can write 100 if you're in a class that doesn't worry about the ambiguity of the zeros, or you could write it as 1.0 times 10 to the 2, depending on the complicated nature of your course and how you decide to express trailing zeros. So here we have C. Nitrogen is what we're interested in. So 1 mole of this compound is equal to just 2 moles of nitrogen. Now, when we do the dimensional analysis, we've got to start with the starting quantity and the starting units. C₂₀H₂₄N₂O₂, whole bunch of stuff in there. Now we want the moles of compound to cancel, so we want that to be on the bottom of the fraction. So we'll cancel that out, get it out of our mind. On top, we need to have 2 moles of nitrogen. Okay, you punch this in on our calculator, and you get that. But don't forget, you need to have two significant figures, so add a 0 to maintain two sig figs, and write moles of nitrogen. Okay. Thanks for watching, and please consider subscribing.